behind you. Hey, how's it going, everybody? Nice to see you. But don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm an actual person presenting the show, and everything that you see in purple right now is going to be one enormous screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for a projector system, it's hidden just below that purple globe. And folks, I'm very excited to announce that the show that we're going to be doing right now is different from all the other ones that we've done here today. This one's called Tour of the Universe, and this show is completely live, so you're going to hear my voice for the next 30 minutes. And what this show entails, well, we're going to be starting off pretty close to our planet Earth, and we're going to be zooming all the way out to the very edge of the observable universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things, so just want to forewarn you. But before we get started with the show, folks, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time. There's quite a few of us in here. First off, there's no food and drinks allowed in. If you brought any snacks, make sure those are put away till the end. We want to keep the theater as clean as possible. Also, folks, if you brought any cell phones, smartwatches, anything that produces bright white light, now's the time to put it away for the next 30 minutes, as these could be very distracting and takes away from the planetarium show experience. And folks, if you need to leave early during our show, the exits are always at the top of our planetarium, so always make your way up the stairs to exit. But if climbing the stairs poses a challenge for you because the stairs are quite steep, don't worry, we understand that as well. Just remain seated. Once the show's over, we'll have someone escort you to a lower exit once the show is finished. And lastly, folks, this show is quite immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you gotta do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, folks, it looks like we're ready to go. So I invite y'all to sit back, relax, gaze into the dome before you because here comes Tour of the Universe. Alrighty, folks, as I mentioned, we're going to be starting off pretty close to our planet Earth. We can see the big blue marble just down below, but we're floating just a little bit above it here at this really cool contraption called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth, and they conduct all different types of science experiments much further away from the planet that they can test the effects of low gravity. And some of the experiments that they'll conduct up here are things like what happens when you try to grow plants in space, how does the low gravity affect them, which way do the roots grow if there's no gravity trying to pull them towards it. And also another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compare and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower, but not only that, you also lose a lot of muscle. Because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, we would recommend exercising daily. Hee hee hee. And also, folks, this space station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. And if you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's about how big it is. And also, folks, what's really impressive is that this space station is traveling at an incredible speed. It's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this looks really far away from our planet Earth, but it's not that far either. The International Space Station is only about 225 miles above the surface of our world. 225 miles. For us Californians, that's not too bad. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, not too bad. But to tell you the truth, folks, this is as far as we put humans out into space nowadays because, again, traveling into space is quite costly. You got to buy yourself a rocket ship or buy yourself one. And then you have to account for all the rocket fuel to get you off of our planet. And then once you get all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space as well. So the bill gets quite costly quite rapidly. But for now, folks, we're going to see the International Space Station slowly disappear to the land below. In fact, it looks like we're hovering just above San Francisco. We can see the bay just down below. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can keep track of it as it slowly disappears. Alrighty, folks, we've zoomed all the way out and we're now able to see our entire planet Earth. And folks, as we're looking down at our planet, I also want to let you know that the space program that I'm using here in the Morrison Planetarium is something that you can go home and download and you can fly through space just like how I'm doing right now. The space program that we're using in here is called OpenSpace. And OpenSpace is an open source software, which means anybody can add to it if you know computer code. But just a heads up, this program is in its beta phase. It's not completely finished. We may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And also, folks, OpenSpace uses a whole lot of processing power and information. It pulls information from satellites. So if you have an older computer, you may not want to download it. But if you got something new, like a gaming computer, give it a try. It's a whole lot of fun. And if you're looking to download this software, you want to go to OpenSpace Project. Otherwise, you'll get a website for a furniture store, so OpenSpace Project. But if you're a person like me that wants to fly through space without having to download anything, well, we also have another great alternative called NASA's Eyes. Just like the human eyeball, go to your favorite search engine, type in NASA's Eyes, and you can fly through space without having to download anything, and it's so much fun. But in here, we're using OpenSpace. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, the last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. And pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out here in space. And the moon is the perfect stepping stone to figuring out the logistics of how we'll be doing that. And what's really cool about Artemis is that they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to do much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is going to be the south pole of the moon. The reason why is because we found ice there. And ice is going to be very helpful because we can melt that ice, pass electricity through it, and collect hydrogen and oxygen. And both of those are very valuable when you're out here in space. So look out for any news about Artemis in the coming years, folks. We humans should be heading back to the moon relatively soon. And folks, when we look up at the moon here from planet Earth, sometimes the moon feels incredibly close, feels like you can reach out your arms and touch it. But the moon's incredibly far away. It's about 240,000 miles away from our planet Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. Astronomers instead use a more convenient measurement known as light speed, and light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days traveling to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the Earth's orbits as they start to slowly fade away. In fact, let me add some nice planet trails so we can keep track of all the stuff here, because again, space is really big. You can easily lose things out here. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace, showing us the most accurate information and images available to us. And now the nearest star to us, the sun, should be coming into view. So here comes the sun. Do-do-do-do-do. And folks, the sun is also incredibly far away from us. It's about 93 million miles. Whew, 93 million miles. That is a good distance away. And again, we're on planet Earth, the third rock from the sun. So 1, 2, 3, 93 million miles between us. In order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes to travel all the way to our planet Earth. And then this is a really cool concept to keep in mind, folks, because let's say the sun was to turn off all of a sudden, there was no more sunlight being emitted. That last bit of sunlight will travel that 93 million miles, that 8.5 minutes at the speed of light. Then all of a sudden, the daytime on Earth would become nighttime. And again, this is such a cool concept to keep in mind because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to travel to get to us. So when you look at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have in our solar system. And again, right in the middle, we have our star, the sun, the biggest thing by far. The closest planet to the sun, we have Mercury. Then we have Venus, Earth, that's us, and then Mars. And these are all the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it looked like if you were to highlight all the asteroids in the asteroid belt. There is a lot of them, folks. And then past the asteroid belt, you have the really big planets. You have the gas giants, the Jovians. You've got Jupiter, the largest of them all, right behind the asteroid belt. Then we have Saturn, famous for its rings. And then we have our icy gas giants. We got Uranus, the funny one, and then Neptune right over here. And we can always add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen. So it's a little bit on the right-hand side of our screen right over there. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt for you. So the Kuiper Belt is like a second asteroid belt way out here past the orbit of Neptune. And what you're mostly going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. And in 2006, we found more than 400 objects, and some of these objects were bigger than Pluto. And we couldn't call all these things planets. There was just way too many of them. So all the astronomers on Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet, and they came up with 3 main criteria to be considered a planet. And unfortunately for Pluto, that was the day it went from being a planet to a dwarf planet. So that's the really cool thing about science, though. As our technology gets better, our telescopes, we're able to see much smaller objects much further away, and we're able to redefine, reclassify the things that we know. So science is constantly changing. But for now, folks, I'm going to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which flew by Pluto in 2015. Now, all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours, roughly about 5 hours to get all the way to Pluto. So only 5 hours to get this far. Not too bad. And again, at the speed of light. But for now, folks, it's time for us to leave our planetary scale behind us because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And now from all the way out here, folks, our star becomes one of many stars in our star field that we see. And Alpha Centauri just appeared on the very top right of our screen, so you can see a star that's moving pretty quickly. So right there on the very top right. And again, we're right in the middle of our screen right over here. And again, 4 years at the speed of light just to get to Alpha Centauri. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Folks, if you're to get in a rocket ship of today's capability, it's going to take you roughly about 8,500 years to make that trip. Whew, I don't think I could live that long. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the Radiosphere. And again, folks, we're now inside something called the Radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before this. But the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, folks, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets outside of our solar system, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue, because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if you look right behind our radiosphere, you can see that we pointed our space telescopes in one direction and we found a whole heap of exoplanets. So as they continue to scan more and more of the night sky, we'll be finding exoplanets left and right. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, like on planet Earth, well, we cannot answer that question quite yet. New space telescopes are being developed right now, so they're on the drawing board. So we got a little while before we can, those are launched into space and we can get a better understanding of that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signal. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, let's give a quick example. Let's say we live in a star system on the left side of our radiosphere, right over here. We find an alien civilization on the right-hand side, somewhere over there. We shoot them a text message. We say, hey, we're humans. We live here. It takes 60 years to get to them. They listen in, answer back. Another 60 years to get the response. Folks, that is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet. But eventually, they will, as the radiosphere is constantly growing, but it becomes weaker as it does. And for now, I'm going to be putting away our exoplanet marker, but I'm going to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, folks, we're now looking down at our Milky Way galaxy, the galaxy that we live in. And I've got to ask, can anybody see their house from all the way out here? Just kidding, we're way too far away. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that is a good distance as well. And folks, the Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you what it looks like from a sideways perspective. When we look at the Milky Way from the side, you're going to notice it kind of looks like a big flat pancake or a frisbee. And this is important, folks, because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of our Milky Way galaxy, which has planets, stars, gas, debris, things that block their view of the universe. So again, keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. And in this giant leap, folks, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group, which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture expands, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or voids. So we can see some nice galaxy clustering towards the center of our screen. We can see some more clustering towards the bottom as well. We can see very few galaxies towards the top left of our screen or voids. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, the picture that we're now looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, who worked at the University of Hawaii, who compiled this amazing representation thanks to works of dozens of other astronomers working beside him over decades of time. So big shout out to Dr. Brent Tully. I love flying through this galactic map. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing that's not a star, that's an individual galaxy. Whew, I feel small. And also, just to let you know, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big, flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way galaxy, it would line up just right down the middle, vertical, just like so. And again, we like to point our telescopes galactically north and galactically south instead of looking to the plane. But astronomers still want to make sure that there was galaxies through the plane of the Milky Way. So we had this nice purple survey of galaxies. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for that technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. And it looks like we're running close out of time on our tour of the universe, folks. 30 minutes is just not enough, to be honest. So let's continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by orange dots on either side of the large-scale structure of the universe. And quasars are short for quasi-stellar radio sources. And these blazing objects are all billions of light years away. So we're now looking so far back in the depth of time and space that the earliest quasars represents the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. And what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And this picture is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back home towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. And this looks like a good spot right here. And let's make a return trip back to planet Earth, everybody. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, folks, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope. And there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. And it looks like we just made our way back into our Milky Way galaxy. We're heading straight for that radiosphere. And folks, if you want to share this show that you just saw right now, you can go to the Morrison Planetarium YouTube page or our Facebook page, and you can see this exact show so you can share with friends and family, because it's honestly a wholesome experience. But now it looks like we're making our way back into our solar system, our star system, our little neighborhood in the vastness of space. Now we're about to pass those spacecrafts that we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt region, making our way to the third rock from the sun, our homeworld planet Earth. All the people that we know, love, ever learned about in history, all lived on this one planet. Now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our tour of the universe. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound just in time for dinner time. And I hope y'all had a great time. Thanks for stopping by, everybody. Have a great night.